Alright, so I thought a little bit more about how we should approach this. I didn't think do any research on the actual technical side of it, but I did think about how we should proceed, what we should implement first. And I think the best thing to implement is, this workflow of actually getting the monitoring set up, because that would be helpful to actually debug issues and stuff later on when we actually do the eBPF firewall implementation. So what we'll try to do today is get the actual probe setup, and if we can get the uh, logs in like a central place. Again, we don't want to be doing a lot of log aggregation and stuff like that at the kernel level, because that is going to be like a huge hit on performance. So we want to like send these to the um, user space, and then have the user space program take care of actually matching the logs and all of that stuff, right? So that's what we will attempt to do today. I'll explain the the setup. It's actually very simple. So I have made a DigitalOcean droplet, which I've added it. So there are two Python servers running on the application itself. So there's one running on port 3001 and another running on port 3002. They're both just simple Python servers, um, and like using http.serve, right? Um, but I have set up an IP tables rule so that blocks port 3002. So simple D port 3002 reject. The idea now is that our eBPF, if you remember the template from yesterday, is an allow all policy. So we should be able to see that our eBPF rule is working as expected. It's expecting everything to be allowed, and everything is actually allowed. But there is a difference between what eBPF is doing and what IP tables is doing. So between this and this, there's a difference in that port 3002 is blocked right now by IP tables, right? And that's the idea. So I'll just show you the experimental setup quickly, and then we'll get right to it. Alright, so setup is very easy. We have a server running on that IP. The IP, don't try to do any shenanigans. This is just a temporary IP. So after I record this video, I'm going to be taking the server down, and it's a server I literally just spun up anyway. There's nothing on it. Um, and this says hello, hi server 1, and 3002 is supposed to say hi server 2, but it's rejecting the connection. It's because this machine has an this machine has a reject rule in the input chain, so it just rejects everything that goes to port 3002. Now, I know that this is not the right way to do it, because this actually would reject connections, like any connection going to 3002, regardless of whether it was intended for this, or like it would even reject essentially loopback connections and stuff. But that's okay for us. So actually, does it reject loopback connections? I think it does. Oop. Yeah, it does. So we ideally want to put like a filter there saying that it should come from the internet, or maybe it should come from the eth1, or uh, whatever the interface is called. Really, okay, let's just yeah, eth0. So if it kind of comes on this interface or something like that, you can do all of that later. But for now, this is good enough. Oh, something interesting, and this is completely and utterly irrelevant to the discussion we have at hand. But so DigitalOcean does this in a very interesting way. So there are two interfaces, one with the private subnet on it, and one with the public subnet on it. This is very similar to what you'd have in, for example, a on-prem setup, right? I mean, on-prem setups can vary wildly, but this is one example. But an AWS would not do it this way. I'll just explain that for fun. In AWS, you would have uh, each host would only have a single interface on it. Let's say eth0, which would have your private IP, you know, x.y.z, right? And then the public interface is a separate uh, resource outside called an NAT gateway. And then this is what, so if you actually try to send an IP to the public internet from here, it gets routed through the NAT gateway and goes like, it does a NAT, or like the NAT gateway does NAT, which is what it's supposed to do, and exposes it with the public IP here. So on the host itself, you actually don't have access to the public IP at all. But on DigitalOcean, you actually have like two interfaces, one with the public IP, which is just an interesting tidbit. All right, so that's about it. It's very simple setup, and again, the servers, if you want to see that, I'm literally running it with Tmux. I probably used the server. Ah, damn it. It's running somewhere. I forgot what the session name was. So I used like a named socket, and I've forgotten what it is now. It's fine. But it is running. Probably you can find it using PSAX. There we go. So that's it. Right? Super simple. Now, getting back to our code, I did realize why this was not giving me any suggestions yesterday. It's because the way Rust Analyzer setup is it's not actually, it doesn't work with mono repos, so it's not able to detect that cargo file. So it just doesn't work. So you just open it separately, and then it gives you everything, which is interesting. Cool. So today we are not actually going to touch this at all, right? Because what we want to do is not XDP. It is the probe stuff, I assume. To be honest, though, I have no idea. I'll have to figure it out on the fly. Okay, so there is example of how to parse packets over here. Um, it seems like we have to literally get pointers by uh, specifying the offset, which is, well, an interesting strategy. I don't know what you do if the headers are of variable lengths. But in this case, we just need the TCP header, UDP header, stuff like that, all of which come from either the Ethernet or the IP headers, which are fixed length. So we should be good. Otherwise, like doing stuff like this, or like this is asking for a buffer overflow. If you just minimize the size of the headers, because this is a fixed offset, and then if, let's say, these header sizes were variable or something, you can make those headers smaller on purpose and then have like a buffer overflow exploit. But we should be good because Ethernet and IP headers are, I believe, fixed size, so we should be good. Okay, trace points, probes. Let's see if we can get some code here. For the demo, we're going to rely on irlog to print IP addresses. This is beautiful. Okay, so I think we want to do something similar to this. Oh, and the context here is different. The context here is a probe context and not a XTP context. So we might have to deal with it in different ways. But should be okay. I've had the song for Elusive Samurai stuck in my head for a while. Okay, this looks relatively straightforward. Um, but we need to find out where this actually hits the stack, right? So I need, if you remember our little um, diagram from earlier, we need a probe point both before and after the the filter. So if we can make both of these actual like eBPF probes, that'll be fantastic. If we can't, we might have to do this probe as part of the actual XDP layer. This would be like the probe layer, and then I don't know what to do about this guy. So let's read more. It's a lot of reading. Ah, I see. So this is actually you're attaching it to different functions. TCP connect. What would really help is if we could find like a diagram that shows all the different functions that are called. I'll make a shorter video explaining everything at the end once we have everything set up, right? Okay, there we go. Predefine events in the current traceable sensors specific. Ah, so kprobe is before a function's called, kret probe is after a function's called. That's useful. Um, Now what we need to know is if TCP connect, I would assume TCP connect ends um, after like the actual connection is formed, which would be at this point, right? Which should be after your IP tables and stuff. So what we need to know is basically, I think if you do a K probe at TCP connect, you get this information, and then a KRET probe, you get this information. We should also try to change our eBPF program to reject some packet so that we know we can differentiate between this and this, because right now this and this are the same. But we'll do that after we set up these two probes. So let's get started setting up the probes. Um, and I think there's some like tooling that helps us automatically make this stuff. This generates Rust. Oh, okay. That's not particularly useful. For now, at least. Okay. I think we'll just have like create um, yeah, we'll have to create the files manually, which is okay. I just don't know how that would work with this. Right, because our eBPF program is going to have multiple um, e- we're going to have multiple eBPF programs within our like user space program. We're going to have like multiple probes and stuff. So it would have been nice if there's like a CLI for this, but maybe not yet. Let's just do it manually for now. Okay, I think what we should do is literally, I mean, they're saying build eBPF here. We should change this to make it so that it's build uh, firewall and stuff like that. So I think we should just do some reorganization here and especially change the names of these things from daemon to something else. Because daemon, I think, will be like a collision. But firewall daemon, that's fine because this is a daemon. Um, or maybe we should like call it. We should make a project name. I'm horrible with project names. So um, let's call it. I don't know. Okay, let's ask our good old friends in ChatGPT to help us. Alright, I'm not breaking this on the stream because it has a bunch of stuff that I've done before that I don't want to necessarily show everybody. But I'm just going to type in, please suggest a one word name for a firewall tool that sounds modern. Forty Shield. That sounds too much like the 40 net, like the firewall hardware tool brand. FireGuard. That's better. Let's try a few more. It did 40 Shield again. Securify. It's all kind of boring. Please generate 10 names. Do not use parts of names of popular firewall companies. It stopped working. God damn it. Let's try again. Secure a wall, NetGuard, Firelock, Shield Core. Wow. Breach block. Okay, no, thank you. Please generate. Okay. We'll think of names later, I guess. But um, let's just make it so that Okay, let's change this thing to firewall. And then we'll have to change the X task for it as well. So this would become build firewall. And then this is search whether this thing has eBPF. There it is. So we'll need to get rid of this and say firewall. Firewall. eBPF build firewall. Okay, I think that's good. We will need to change this. Is there a module definition of that? Don't think so. Yeah, use grid. Okay, build firewall, build firewall, build firewall, build firewall. We need to change that function name as well. And then this, what is this? Oh, this is the actual command. So this should be build firewall as well. Nice functional pattern. And then run should have similarly build firewall. And then is there any like eBPF here? Guess not. So that's good. Did I miss anything? Guess not. Then the cargo might have something defined. Nope. Okay, that's good. And then build firewall. There's a function in here called build eBPF that I need to change. And the path here changes to daemon firewall. Okay, that should fail to build firewall BPF program. I think that's it. Okay, now this should go. Should say programs. Okay, so that's cool. What else do we need to change? Cargo terminal looks okay. Why is the workspace here? Why does the workspace here not contain the firewall program? I don't actually know. Let's try that. Okay. Now we should be able to just run a cargo x task build firewall. Oop, multiple workspace roots found in the same directory. Oh, that's why it was not included. Lol. Okay, cool. So that does work. Let's get that. Oh, well, probably should. Looks like I'm still tired. Uh, hmm. It's probably because there you go. Cool. And now we need to go back and actually we need to go create the. Okay, so since we're going to have two different um, probes, right? We're going to have a return probe as well as a entry probe. Those should be two different eBPF programs. So let's work on just one of them first. We name that to daemon probe entry. Put it in there. And okay, we'll have to go through everything. This seems okay. I don't know what this is, to be honest. I don't think we actually need these because I don't use VS Code or Vim. We'll get to that. Cargo lock. The log file should be okay. And then here, oh, the package name. We have to change this in that one as well. Almost forgot this. Daemon. Let's just get that. Actually. Okay, I'll push that later. Don't need to exit out. Just go there. And let's not make the same mistake twice. Let's go call this probe entry. Everything else looks okay. Rust toolchain should not affect anything. Don't think so. And then over here, I don't need to go. Actually, don't need to change a lot of this because this is not going to be an XDP program. It's going to be a kernel program. Sorry, a pro program. But we'll keep that for a bit. We don't need to change our Xtask stuff. Actually, maybe we should just go and delete all of this. Or we can just copy the template from the program types here. Right. I have no idea if this actually works yet, but it should be okay for now. And then we have to go in here and actually create a new build process for this. Build probe entry, and should be relatively straightforward because Okay, that should be everything that we need to change, but let's just go through this file and see if it's doing something that's specific to XDP. Should not be, but you'd never know. So architecture, this should be okay. Display for architectures, options. Okay, it's doing some architecture stuff again. Okay, doesn't look like it's doing anything specific for XDP, so this should be good. But we also need to go and change our build time stuff, because now the build program has to run multiple builds. It needs to run build probe entry as well with the same build options, which makes sense. And then it's doing this. Cool. And then we definitely need to add this actually has architecture and stuff defined multiple times. I don't think we need that. I think we can use like a common set of architecture and options. Options come from here. I think we can, because every eBPF program should be constrained by the same options. Yeah, so let's just abstract this out. I think that should be okay for now, at least. Parser, where's this being used? Okay, over there. Path buff is being used there, and command is being used somewhere over there. So we can take all of this stuff and put it in build properties eBPF. Something like this. And then go here, get rid of this, and build.rs. Great, build eBPF common, like that. This do, wait a second, okay, these are the common ones. Do this. Is architecture even needed here? Doesn't look like it, but options definitely are. Do this and do this. Okay, and then the build should need this, and then it also needs right. I already use this elsewhere. Yeah, cool. And then in main.rs we need to create a new command for building the probe entry. then this should just be build options. I don't know why I keep writing probable. That makes no sense. But it's okay. I don't think we need to change anything here. Oh, we do. Ah. Okay. Cool. Build probe again. Okay, that didn't work. File not found for binding. I assume this is uh some like dependency issue. Let's see. Use create binding. There we go. Okay, it says mod binding as well. So let's go over there. There is a binding for others. Oh lol. What's up with this? That's a very scary file. That's a very long, scary file. Oh, this is probably one of those files that was generated with IR tool. Automatically generated with REST bind gen. I need to figure out how that was done and why that was done. It doesn't actually specify. That is scary. That is a bit scary. I need to figure this out, but for now, let's just... What the heck is up with that commit message? For now, let's just copy paste it. $42,000 lines of code. Okay. There's no way I'm figuring out what that is. I'll need to figure it out by reading something somewhere. Why did you fail again? Error linking with eBPF linker. Oh, actually no. Let's see what requirements you have. Oh, is it because I don't have this keyboard? Oh no, but that's a common stuff. I have both of these. Okay, let us figure out. Let us figure out what the differences are here. I think the big one is if um, the X task here actually does something different. This is just X task. And then does do either of these two do anything different? That's what we need to figure out. Does this happen here? Build proprietary. It does not. Oh, it does. It's over there. This seems to be the same. This is almost definitely the same. That is unfortunate. Linking with BPF linker failed. Why? Okay, what is it failing to link? This is utterly useless. I have no idea what this is. Okay. You want to just try deleting all the artifacts once? Good old hacks. This is the path, right? // Yes, it is. There is no good result here, whether it fails or not. If it fails, as it did, it just means that, it didn't fix anything. But if it didn't fail, that would just mean that, hey, the build is fickle. But at least it didn't fail. That means the build isn't fickle. Oh, is this because I did not set the architecture environment? Is that used somewhere? I think it might be. Oh, not over there. Cross compilation. Is this required or something? Okay, that's not it. Can't be sure until I do this. But I don't think that's it. Okay. Time to Google. Could also be because of that binding code. Is there a code gen task? Huh. Okay, let's try actually using our IR tool to generate the bindings. So let's remove this one and do the condenser as well. Oop. Okay, let's do it. Copy paste. Copy paste is lovely. Okay, now I need to figure out what to actually. IR tool got installed. That's great. IR tool. Okay, so we need to figure out what the bindings are being used for, right? And for that, I need to. This is the build stuff. I need to go into the main.rs file. Inside this, there we go. So I need like sock common. What's being used inside sock? I think they're literally just called sock and sock common. Okay, so then I should just be able to do this. Sock common daemon probe resource bindings.rs binding.rs. I need to install BPF tool. Damn it, this is asking us to set up Goliba and stuff. I don't want to do this. Installation, come on. Ah, damn it. Okay, I'm gonna just do a Hail Mary here and say BPF tool. Nope. eBPF BPF tool. Great. Search your boo. There's a bunch of like. Oh, okay. Oh, this is the man page. Don't want that. I don't know if BPF tool can be installed on a map. That's gonna be a blocker. Oh, the learn more page doesn't exist. Oh god. Man, I might have to set up Golema and like a VM environment for this. This is just installed natively. uh, oh man. Should get a Linux box again. I don't know if I can build this. Let's see. Libelf. Should be able to build it. Let's do it. Missing separator. Oh, this is because probably into something like this. Oh no. It's not gonna be fun, is it? Well, that works. That doesn't work. This actually doesn't have lib. Uh, this just says LLVM. So I don't know what this stuff is. Uh, libbfd. This is why I hate working with like old build systems that don't have the like like a proper package manager. You'll like hit your head against it if you don't know what they're doing. Yeah, I don't think this is happening. I'm surprised it's not like a homebrew. But it might literally not be possible. Okay, I might have to set up a Linux environment for this then. It's trying to not do that, but well, what can you do? But why does this need BPF2? I could try installing this over there, but then I'd have to like get the crate. This doesn't even have a bus on it yet. Let's do it. Rust up not installed. Okay, why? Because I haven't sourced it. Linker not found. Install build essential. Come on, do the build quicker. Uh, this is it, right? Huh. I don't even think this is the actual requirement anymore. What is this sock and sock common? I'll have to read about what this stuff is later. But I think just to unblock our work on actually seeing if this works, right? That should be okay. That still didn't work. Why? Oh, unused import, mismatched types. Oh, because I'm not returning. That's okay. Okay. There you go. Now you should be happy. What are you not happy about? 3 warnings emitted? No sock common because I'm trying to do this. There we go. So it does work. It's just that, actually getting any code in here working is not going to be trivial, it seems. But that's okay. That is okay. Okay, let's go ahead and git add dot get some scaffold fire probe tree. So that. And now we need to go through the arduous task of actually figuring out what is up with the binding file that doesn't exist. What's up with all of this stuff? Okay, let's see. Of course, that doesn't work because of the same issue with the Rust analyzer. Let's see. Program types, probes. So what we'd like to do, Okay, why would a file called tcpconnect.c contain a function called tcpconnect? I was, far too stupid to think that it would. Might be in tcp.h. tcp. Okay, where is this? This is an RDS, that's why. We should go to net. Net. Net filter, but no net. Oh, this is under net. Fortunately, this doesn't point to the actual function call. Is that it? What is this? Open on load. See some IP stuff. I'm not even entirely sure what RDS is, to be honest. Pretty sure this is not what we need. These look like individual net stacks or something. Is it under kernel? Guess not. Okay, let's go to the actual Linux kernel. Well, the Linux kernel mirror. So I'm going to be on the lib. Interprocess communication in it include FS drivers. There's so much here. This is definitely like proprietary stacks or something, right? It's like TLS here. I don't think I can do a search through this, but let's see. Wow. So what is the signature that these guys are connecting to? What the? Oh man. This is Elixir. But it says net IPv4 TCP output. So that we can go here now. And I did see that folder. I don't know why TCP connect would be under. Oh, it is. There's a bunch of TCP functions here. Why is that under IP? TCP output. Should we search for that here? Connect. Yeah, there we go. Okay, cool. So this is the socket. And we need to figure out what socket type this is. Where does this come from? Assume that comes from one of these bad boys. The only one that it could come from are these two, I think. Is there a socket here? net/sock.h. Type def struct sock. That's the definition, or at least the declaration. And sock comment. There it is. So we found the socket definitions, but now we need to figure out how to generate those with IR tool. For which still need to do this. We can do that yet. See, the actual coding is not the hard part here, is it? It's getting the actual toolchain set up. The coding looks relatively straightforward for now. I wonder if I can do two at a time. Let's try. So here I just specify the name. It's not even asking me for like where the location is or something. We'll figure it out. Now we're just waiting. The package name is Knob. It's interesting. Pretty please finish quickly, am I right? Almost there. And check if IR tool's working. It is, okay. If this produces the exact same file, it'll be very funny. 49,000 lines. That seems too close for comfort. But let's do it. CD workspace. Oh, should be the other one. Okay. I should have worked. I'm begging the gods to please make this work. Okay, that failed. Because I have this OK0 here. Oh no! Oh no! It is on this depressing note that I will end today's stream. Uh, guess I'll have to try to set up the like a full Linux environment with like a VM in where I'll actually do the builds and stuff. Yeah, it's not gonna work. Could try to figure out where this is coming from. It's coming from. Hard to say. It's a dependency. Well,